Adipose tissue is increasingly recognized as one of the largest and most dynamic immune organs in the body, a hub where metabolism and immunity are intimately intertwined. Far from being an inert fat depot, adipose tissue houses a rich diversity of immune cells, including macrophages, T cells, B cells, dendritic cells, and innate lymphoid cells, all of which engage in constant crosstalk with adipocytes. This interaction enables adipose tissue to function as an active immunological center, sensing pathogens, responding to tissue stress, and orchestrating inflammatory or anti-inflammatory responses that affect both local and systemic health. Under healthy conditions, adipose tissue maintains a finely balanced immune environment that supports insulin sensitivity and tissue homeostasis. Anti-inflammatory immune cells such as M2, like macrophages, regulatory T cells, Tregs, and adipocyte-derived anti-inflammatory cytokines, including adiponectin and interleukin-10, IL-10, predominate. These factors suppress unnecessary inflammation, promote tissue repair, and support a metabolically healthy state by enhancing insulin action in adipocytes and other organs. Adipocytes themselves are active participants in immune modulation. They express pattern recognition receptors like toll-like receptors, TLRs, that detect pathogen-associated and damage-associated molecular patterns, allowing fat tissue to act as an early responder to infections or cellular stress. In response, adipocytes can secrete a spectrum of cytokines, including both pro-inflammatory signals like tumor necrosis factor alpha, TNFA, and interleukin-6, IL-6, and anti-inflammatory mediators like adiponectin and IL-10. This dual capacity allows adipose tissue to quickly mobilize immune defenses against infections or injuries while maintaining a homeostatic anti-inflammatory tone during periods of metabolic balance. The protective immune functions of adipose tissue are especially apparent in subcutaneous fat depots, which, when healthy, buffer systemic inflammation by producing anti-inflammatory adipokines and housing regulatory immune cells. This helps dampen chronic low-grade inflammation, a key driver of insulin resistance, atherosclerosis, and other metabolic diseases. Conversely, when adipose tissue becomes overloaded or stressed, as seen in visceral obesity, the immune balance shifts toward a pro-inflammatory state. Hypertrophic adipocytes release chemokines that recruit pro-inflammatory M1, like macrophages, cytotoxic T cells, and B cells that produce inflammatory antibodies, all of which amplify local and systemic inflammation. This state not only disrupts insulin signaling in fat, but also spills over to affect liver, muscle, and vascular tissues. Moreover, adipose tissue has been shown to respond to infections directly. Studies in animal models demonstrate that adipocytes can store and present antigens, recruit immune cells, and produce acute phase proteins that contribute to the innate immune response. Some researchers propose that adipose tissue serves as a safe harbor for certain pathogens like Mycobacterium tuberculosis, underscoring its active role in host pathogen interactions. Importantly, recent findings suggest that interventions that restore immune balance in adipose tissue, such as exercise, calorie restriction, or pharmacological agents targeting inflammation, can dramatically improve metabolic outcomes. By reducing pro-inflammatory immune cell infiltration and restoring anti-inflammatory signaling, adipose tissue can regain its role as a buffer against systemic inflammation, thereby enhancing insulin sensitivity and lowering the risk of metabolic diseases. Altogether, these insights show that adipose tissue is a highly immunologically active organ that does far more than store energy. Through its resident immune cells and dynamic cytokine production, healthy adipose tissue actively protects against infections, regulates inflammation, and supports metabolic harmony. Dysfunctional adipose inflammation, not fat mass itself, drives many obesity-related diseases, highlighting the critical need to preserve or restore the immune health of adipose tissue. Far from being merely harmful, fat tissue, when functioning properly, is a key immunometabolic regulator essential for resilience against metabolic and infectious stressors.